Okay, so now in this video we're going to find all zeros of a polynomial. So not just the real zeros, but all zeros. Alright, looking at this, I can't factor it really easy to begin with. So I'm going to go ahead and use the rational zeros theorem, which says that if you take all possible factors of the last term and divide that by all possible factors of the first coefficient, then you can find all possible factors. So let's go ahead and do that. So in the rational zeros theorem, so this last term was, we used like this p. So the possible factors of 4 were plus or minus 1, or r, plus or minus 1, plus or minus 2, and plus or minus 4. And then the possible factors for the first coefficient are plus or minus 1, because the first coefficient is just 1. Okay, so then if you do p divided by q to find your list of possible factors, you just get plus or minus 1, plus or minus 2, and plus or minus 4. Alright, so we need to, test out our factors using synthetic division. So I'll go ahead and just do a few, and yeah, I mean, it can take you a while sometimes to find your factor, but I'll go ahead and start with a factor of 1. So my coefficients here are 1 and then 0. 0 is a placeholder for x squared because there's no x squared term here. And then there's an x and then a 4 and then the constant 4. Okay, so bring this one down. 1 times 1 is 1. 1 times 1 is 1. Negative 1. 1 times negative 1 is negative 1. And then this is 3, which is not a 0 because it has a remainder. Let's go ahead and we'll try negative 2. 1, 0, negative 2, and 4. Drop the 1. 1, negative 2 times 1 is negative 2. Negative 2. Negative 2 times negative 2 is 4. Okay, add these. Negative 2 plus 4 is 2. Negative 2 times 2 is negative 4. And the remainder is 0. Okay, so negative 2 is a 0. You can go through and test all of them, and that's how you can find it. Also, you might be able to use a graphing calculator and graph the polynomial and kind of see about where the 0 might be. Of course, zeros are where you cross the x-axis, right? Where y equals 0. So you can kind of maybe look at a graphing calculator, check this out. But in the end, if you test them all, you'll find that negative 2 is one of them. Okay, so this is a 0, negative 2, so I can rewrite my polynomial p of x. I can use my factorization, so this is corresponding to x squared, and then with x, and then that's the constant. So 1x squared minus 2x plus 2, okay? That times the 0, so x plus 2, right? So now looking at this, again, this is not easily factorable, but at very least I can use the quadratic formula to factor it, which is a lot faster than anything else. So we'll go ahead and do that. We'll use the quadratic formula. So we'll have, well, from here I just want to say x equals negative 2. We know that. That's one of the zeros. Okay, so I'm looking at this here. So x equals negative b plus or minus square root of b squared minus 4ac over 2a. Okay, so now let's go ahead and plug it in what we have. B is negative 2, so negative b is 2, plus or minus b is negative 2, so b squared is 4, minus 4 times a times c. Okay, so a is 1 and c is 2, so 4 times 2 is 8. All over 2 times a, which is 1. Okay, so this is 2 plus or minus the square root of negative 4 over 2. Now the square root of negative 4 is what? Square root of negative 4. So that would be the square root of 4 times the square root of negative 1. So that would be 2i. Okay? So the square root of negative 4 is the square root of 4 times the square root of negative 1. So that's 2i. Alright? So let's see. Now I can break this up. So I have 2 over 2 plus 2i over 2. So this is, plus or minus. So that would be 1 plus or minus I. Alright, so what's my answer now? What are all of my zeros? So let's write my set. I have negative 2, I have 1 minus I, and I have 1 plus I. Alright, now this is a third degree polynomial, right? The highest degree, so the highest power is 3. So this is a third degree polynomial, and I have 3 zeros. So that means I found them all, right? Because my number of zeros should match the degree of the polynomial. All right, let's do one more example. Okay, so in this example, let's see. I can start by factoring a little bit. I can pull out a x and a 2. So I'm going to pull out a 2x. So then I'll have x to the 4th here plus 8x squared plus 32 divided by 16. Okay? All right, now let's see. I can factor this. Let me use the U-Substitution. So U equal to x squared, and then U squared then equals x to the 4th. Okay, so this term, or this here, can be written as U squared plus 8u plus 16, right? And this is easily factorable. Okay, so this then is u. So what times what is 16 and then adds up to 4? Plus 4 and plus 4. Or in other words, u plus 4 squared. Okay, so if I were to plug back in x, now going from here to here, so I'd have 2x, and then this went to being x squared, because that's what u is, plus 4 squared. Okay, so now let's go ahead and find my zeros. This x equals 0 is a 0, okay? And then for this one, x squared plus 4 equal to 0, then x squared equals negative 4. So take the square root of both sides. So x equals plus or minus the square root of negative 4. Square root of negative 4 is the same thing as 4 times 1, right? Which is plus or minus square root of 4, which is 2. Square root of 1 is I. Okay, so these are my zeros. So I'll list them out. 0, 2i, and negative 2i. Okay, these are my zeros. Now let's check that the number of zeros matches the degree of the polynomial. Well, the degree of the polynomial is 5, and I only have 3 zeros. What happened here? Well, these zeros have multiplicity 2. Okay, so since they have multiplicity of 2, they get counted twice. So this is 2 plus 2 plus 1, so that equals 5. So the number of zeros does match the degree of the polynomial. 2 plus 2 plus 1 is 5.